Hello, 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 ladies and gentlemen, fellow discoverers. Welcome to another episode of David King's Discovery, with your host, me, David King. And boy, do I have a treat for you today. Today, we will be looking at potentially the most important dinosaur ever discovered. So hold on as we look at the incredible Sinosauropteryx. Now hold on before you close the video. I fully know that the two most likely reactions to this would be, oh hell yeah, Sinosauropteryx, my boy, my favourite dinosaur, or, what the hell is that? Which is understandable. Sinosauropteryx is not a very well known species outside of the natural dinosaur lovers. When telling people about my next video, the unanimous response was, I don't know, I've never heard of it. And I get it. Apart from a handful of dinosaur documentaries, Sinosauropteryx hasn't been part of any major, movie or TV show. The most mainstream appearance of Sinosauropteryx would probably be the Jurassic World Evolution 2 video game, but it was only as a paid DLC, so it's not like it was a main character of the game. So if you haven't heard of this dinosaur, I get it, I understand. But you might be wondering why I called it the most important dinosaur discovered. Could it be the biggest dinosaur? The scariest? Not really. It wasn't very big, it wasn't very scary, and it wasn't even the apex predator of its time. The most important part of Sinosauropteryx is the fact that it has feathers. And not only did it have feathers, we have been able to discover, through science, the colour of these feathers. Now some of you might be thinking, so what? Other dinosaurs have been found with feathers. Heck, birds are dinosaurs, they have feathers. So what makes this dinosaur so important? And how can we even tell its colour? Fossils don't fossilise in colour, so how? Well, I shall answer these questions all in due time. So now, let's take a deeper look and discover Sinosauropteryx. Our story begins back in 1996 in China, specifically the Yijian Formation, where Sinosauropteryx was found by a farmer and a part-time paleontologist. Being from this area makes Sinosauropteryx part of the G-Hole biota, a collection of flora and fauna species found only in this area, and this area is home to some of the most well-preserved fossils ever. In fact, a lot of the feathered dinosaurs discovered have been from this area, just because of how well preserved this area fossilises feathers, which are notoriously difficult to fossilise. Now, Sinosauropteryx lived in the early Cretaceous period of around 130 to 122 million years ago, and due to just how well preserved this area is, we have a very solid idea of the environment that Sinosauropteryx would have lived in. It would have lived in a region of relatively cool temperatures of around 10 degrees Celsius, with very distinct wet and dry seasons, with unusually cold winters. Sinosauropteryx would have lived in an area with large open terrains, with also some forests mixed in, full of conifers, cycads and ferns. Sinosauropteryx would have had to be fast and agile, nimbly traversing both the forest and open terrains, being able to chase down its fast-moving prey. In fact, we know what prey it was. Remember how I said the fossils in this region were so well preserved? They are so well preserved that we can see the remains of the last animal eaten by Sinosauropteryx in its stomach. It was a small, fast-moving lizard. And even crazier than that is the fact that Sinosauropteryx was found with fossilised eggs. Now these eggs weren't in the stomach area, so they weren't eaten by Sinosauropteryx. Instead, these were the little baby Sinosauropteryx. This also means that we can tell that Sinosauropteryx would have had dual oviducts, laying eggs in pairs. So, like I said in the intro, Sinosauropteryx wasn't a particularly large dinosaur. In fact, it's quite the opposite. In fact, it is one of the smallest known adult non-avian theropods. The longest known specimen is only around 1.07 meters long, with an estimated weight of around 0.55 kilograms, so it's incredibly small. And you may have just noticed that I specified that Sinosauropteryx was a non-avian theropod, which is one reason why this species is so very important. It is the first non-avian dinosaur ever to be discovered with feathers. Let's delve into this a bit more. Now before I get too far into this, it's really important to note that the classification of dinosaurs changes all the time, and it's always a hotly debated topic of what goes in where, and which dinosaur is in which genus or family, and it always changes. So I'm not really going to get into the nitty gritty of the classifications. Like, we would be here for hours if I was going to go through every single classification of every single dinosaur. And even if I did make this video that detailed, it's highly possible that it will just change within a month or two. I mean, if this video came out just 3 or 4 months ago, Nanotyrannus would still be classified as a juvenile tyrannosaur instead of its own species, but that's how quick things change. So instead, I'm just going to stick to the basics of this, and that is non-avian and avian dinosaurs. So if you didn't know, birds are dinosaurs. They belong to a family called the Aves family, or the avians, and Sinosauropteryx is not an avian dinosaur. It's part of a family Compsognathidae, and whilst this family is related to avians, like sort of a distant cousin, as they're both part of the Sinosauropteryx, it branched off much earlier than the avian side. And this isn't just guesswork here. There are anatomical reasons why Sinosauropteryx, even with feathers, isn't regarded as a bird. One of the reasons is that it has an extremely long tail. In fact, it's the longest tail relative to body length of all theropods, and it had very short arms, even for its size very small, which have been useless for any type of flight or gliding. And whilst we will get into the feathers a bit more in a second, the feathers are not designed for flight. They're much more short and not asymmetrical. These are just some of the reasons why Sinosauropteryx isn't classed as an avian dinosaur. This leads into just how important Sinosauropteryx is in the history of paleontology. You see, it was theorized and accepted long ago that dinosaurs had feathers, long before the discovery of Sinosauropteryx, with the most famous example being Archaeopteryx, discovered in the 1800s, which is one of the earliest members of the Aves family. Sinosauropteryx, however, opened the door on the evolution of feathers, with feathers now not being limited to the Aves family, instead having potentially been evolved long before the adaptation of flight. So it might have been used for display or installation purposes before flying. The other important part about all this is the fact that Sinosauropteryx having feathers and not being part of the Aves family lends a lot of strong evidence to the fact that birds are dinosaurs, which at the time, and even now with some people, is still hotly debated. So seeing that dinosaurs before avians had feathers lends a lot of credence to the fact that birds are dinosaurs. So let's now take a look at these feathers, and despite all my hot dogging and grandstanding, they aren't actually feathers. They're more like proto-feathers, a much more primitive form of feathers. All Sinosauropteryx fossils have been found with filaments coming from the skin. This is evidence of these primitive feathers. Sinosauropteryx would have been fully covered in feathers, with these filaments being found along the skull, arms, neck, back, and tail of the fossils, as well as some random patches along the side, but this is most likely due to feathers not all fossilizing. And not only do these fossils show the feathers, these feathers are so well preserved that we can see and determine the colour of the animal. This might sound like some sci-fi nonsense or some witch talk, but hear me out. When scientists inspected these filaments, they found very well preserved melanosomes. Now, melanosomes are cells in the body that create and store melanin. And melanin, as some of you might know, determines skin, hair, and eye colour in animals. The size, structure, and shape of melanosomes determines which colour they reflect, and thus the colour of the animal. We actually know the colour of a small group of dinosaurs. Now, I'm not going to go into detail of all of them in this video, but here's a quick list of all the dinosaur names. The presence of feathers isn't necessarily knowing the colour of an animal, with these 3 dinosaurs being featherless. The reason we know these colours is due to the skin impressions left in fossils. Another reason Sinosauropteryx is such a key discovery is that out of these select few animals, Sinosauropteryx was once again the first dinosaur to have its colour determined. So, now we know why we know the colour of Sinosauropteryx. What colour was Sinosauropteryx? Well, we would have seen regions of light and dark colours, with there being a distinct counter-shading pattern, with darker reddish-brown colours on its back, and lighter colours along its underbelly to help with camouflage. Counter-shading is still seen in the majority of animal species today. It is an excellent way to blend into the environment to either hide from predators, or to ambush their prey. Counter-shading works by essentially cancelling out shadows created by the animal, so they appear flatter and harder to spot against the background. Sinosauropteryx would have also had a banded tail, with reddish brown and white bands along the length of its tail, and more recently it was put forward and accepted that Sinosauropteryx would have had a raccoon-type mask, making it one of the more adorable dinosaurs in my opinion. That brings an end to our Sinosauropteryx journey, and I hope that this video has done some justice to just how important Sinosauropteryx is, being the first non-avian feathered dinosaur discovered, as well as the first dinosaur to have its colour scientifically established. These 2 instances dramatically changed the course of paleontology. Since its discovery, more and more non-avian dinosaurs have been discovered with feathers, partly because Sinosauropteryx showed that it is possible giving paleontologists the knowledge of what to look for, and it showed that feathers do not automatically mean a dinosaur is directly related to birds, as well as proving it is possible to know what dinosaurs look like in regards to colour. Now previously this was just more of a guessing game, looking at modern animals for representation, in the environment dinosaurs would have lived in, which helps narrow down the colour. And now, due to Sinosauropteryx, we know the colour of a handful of dinosaurs. Hopefully, if you didn't know about this animal, you have learnt something about its significance. And if you did know about this animal, I hope that this video has done some justice in your eyes. Thank you all for watching, I hope you have enjoyed, and remember to keep learning and discovering. Until next time, goodbye.